Hmm.
So today what we'll see, today we'll discuss about the Docker. Okay, so Docker class actually is very easy, and if you understand the commands and remember the commands, it's very easy to write. It's like Unix type of commands. You have to just execute on the terminal and get the details done. Okay, and there are a few Docker
Okay.
files which you have to write to make your own image. Okay, that we need to know how to write that. It's kind of shell script you have to write, like you do shell script, right? Commands one after another, right, sequentially. Similarly, we have to write the commands in a Docker file to execute the and to build it to generate the images. So let's see, we'll try to finish this Docker in the next 5 days. Okay, so
Oh, it will take 5 days.
yeah, it
Okay.
will take five
Will
classes
take
because
five classes.
yeah,
Oh,
five
the.
classes. So five classes
Hmm.
it will take. So today is suppose Thursday, Saturday, Sunday. Next,
Hmm.
by the next Thursday, we'll try to finish it. Okay.
Ah.
We'll
Uh,
have class
So
Sunday.
this time we'll have Sunday class, or Ranjit will skip as you wish actually.
no, no. We'll Sunday we'll skip. I think. See, Sunday you guys just take rest, or also we can add one more weekdays if you want.
Weekdays.
So we have
Uh,
currently Tuesday and Thursday, right?
Tuesday, Thursday, Saturday, 3 days actually.
We have 3 days only, right? Weekly. Uh,
Uh,
one more days we can add, right? Hmm.
Or Sunday 30 minutes extra.
Sunday.
Saturday 30 minutes extra.
Yeah, that can be done. No, no, Saturday will take 2 hours, no problem. Means
uh,
instead of 1 hour, will take 2 hours, right?
okay, Ranjit. Otherwise, next week we'll see if you can add one more. That means in between, not need basis we'll add actually,
Okay, 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 fine, fine.
because weekdays, no,
Hmm.
need basis we'll see. Anyway, Sunday we'll keep it off actually.
Okay, yeah.
Let it be because
Hmm.
yeah, that we will do.
Okay, then we'll see.
Yeah, Ranjit. Let's go ahead.
Okay, so let me share my screen. We'll discuss about the Docker and the containerization. Okay, so we guys have seen, right? In current, see, the market, if you see, there are few full stack developers, like the guy who knows everything from end to end, from the UI design to the backend database DBA part, also database designing. They want a person who can do everything, right? That is full stack developer.
Development.
So in case of Docker, what happens actually? If you would have seen our first class during the DevOps class, right? So there was always, right. I have in one of the slide I had mentioned, like the version mismatch of the systems. Like the developer, whatever he was working in the development environment or testing environment, the product, it might not be the same in the production environment. Maybe some libraries, binaries, or even operating system, the versions are different. Suppose here the higher versions they have developed in development environment or testing environment, they have done the testing. Suppose, and when they deploy the product, that will be in the production, it will be either lower environment. So what will happen, the lower versions will be, it will break in the lower version. So the again the production support guys, they'll claim it, or they'll raise incident, or they'll raise problems, and then it has to be again fixed and redeploy. So to overcome this problem, this Docker or containerization platform came into the picture. Okay, that is called containerization. Previously we had virtualization. In case of virtualization, what was happening, we have one machines to with the help of hypervisor or various other virtualization tool, we make our system to virtualization environment, to multiple virtualization VMs we make, and then we install different operating systems and different applications to make different server but VMs, machines, virtual machines. Okay, but in case of Docker, same concept, virtualization concept is there, but we are making it as containerization. We are making as containerization. So we are same applications and same libraries vanish, whatever was there being installed in virtual machines and VMs. Same thing will be done in the containerization. The only thing and only benefit actually here in containerization is whatever the applications, okay, whatever the applications or applications or products being developed in development environment in a containerization platform, okay, that you can build it and ship it to anywhere. It will not break because we are containerizing everything in one containerization inside one container, and that container will hold your operating system, it will hold your libraries, binaries, and everything. That means it will not dependent on the host machines, though it is using the hardwares of your machines, but it will not use the operating systems, libraries, and binaries of your host machines. That means when you just get it and from development environment and put it in any environment, it will independently work because it has all the required details inside the container. Okay, so let's see theoretical how what is it is and how we can just learn more on that to go ahead and do the practice. Okay, so
Yeah, yeah.
Docker, you can see here the symbol is look like this. Okay, it's kind of
Ship.
blue whale, yeah, blue whale, and inside on top of the blue whale it has some containers. Okay, so let's start. First thing is, what is Docker? Docker is a platform so used to containerize your software, using which you can easily build your application, package them with the dependencies required for your application into the container, and further these containers are easily shipped to run on other machines. So this is only the definitions about the Docker, but you need to understand what exactly it does. Okay, then if you
Yeah,
understand
yeah.
completely, then it will be easy for you to move further and do the practices. Okay guys, don't get confused about this theoretical and what I'm going to explain you. Okay, I'm going to explain you from the basics so that you will understand clearly what exactly it is. Okay,
Yeah, yeah.
so
Correct.
yeah, so what it says, Docker is a platform. Just remember, Docker is a platform used to containerize your software, using which you can easily build your application, package them with dependencies required for your applications. So dependencies means whatever the, suppose whenever you are writing one application, suppose a Java application or .NET application, you need set of libraries, you need set of binary files which will required for that applications to build. Okay, and you are putting everything
Yeah, yeah.
in a container, and then once it is done, you can ship that container to any other machine and it will be run independently. Okay, what again it says, Docker is simplifying the DevOps methodology by allowing developers to create templates called images. Okay, so these images will see how to create. Okay, also how to create, and while creating these images we have to write one Docker file that is nothing but, as I told, it's similar to shell scripting. You have to just sequentially give the commands which needs to be executed one after another, and once it is done it will just build it, then it will create one image and you can use that image to create the container. Okay, so using which you can
Yeah, yeah.
create these lightweight virtual machines. See, lightweight virtual machines called as containers. Docker is
Yeah,
making
it's
things,
equivalent to a machine actually.
yeah,
Lightweight versus BM. Yeah.
lightweight virtual VMs and called as containers.
Hmm.
So Docker is making things easier for software industries, giving them capability to automate the infrastructure, isolate the applications, maintaining the consistency, and improving the resource utilization. So we'll see how the resource utilization can be improved and how the consistency can be maintained. Okay, how isolations of the applications happen. So these things we'll see in details. Okay, so before understanding the containerization, we should understand what is virtualization. Those who don't know what is actually virtualization, for them I'm just going to give small definitions about virtualization, and then we'll move forward to the containerization. Okay, so what is the virtualization? Virtualization refers to importing
Okay.
guest operating system on your host operating system. So you'll be thinking, what is guest operating system and what is host operating system? The host operating system, which is having your laptop or desktop. Okay, on top of that, whenever you are creating a virtual machines, in that virtual machines you are installing another operating system, that will be your guest operating system. Okay, what it says, virtualization refers to importing a guest operating system on your host operating system, allowing developers to run multiple operating system on different VMs. So that what will happen, we'll have one base host machines, and that host machines will have the different guest machines, and that guest machines is called the virtual machines, VMs, and each VMs will have different operating systems. Okay, so what it says, uh, s- um, while all of them run on the same host machines, so they will be using the same host operating systems, thereby eliminating the need to provide extra hardware resources. While these virtual machines were introduced, they helped industry in many ways. That what it says, thereby eliminating the need to provide extra hardware resources. As we create multiple VMs, suppose my laptop is having 8 GB of RAM and 1 TB of hard disk. Okay, and I have created 5 virtual machines. So those all 5 virtual machines are going to use the same resources whatever I have in my laptop. In that case, what happens? We are So before virtualization, what was happening? Whenever you need another machine or another server, you have to go market, buy the laptop or desktops or any hardware components and create one server or create one machine. So it was very costly, and you have to pay for more for that. Okay, and it was
More for that.
actually, yeah, it was actually you have to pay for that, and yeah, it is not actually fit into the market, and it was very expensive. But after coming this virtualization, what happens, you don't have to go for a new hardware or new resources. Whatever you have in same resources, using some virtualization tool, you can create multiple machines. Okay, so those machines, those virtual machines will use the hardware components and resources from your host machine, that is your laptop or desktop. And one more thing,
Yeah,
this virtualization, actually, if you heard about the VMware company, VMware, so that VMware is the company who created everything virtualization, and it has also provides the hypervisor one tool, which creates these virtual machines. We'll see in details. Okay, what it does,
okay,
that
okay.
it enables multiple operating system on the same machines. It was cheaper than the previous method due to less or compact infrastructure setup. If there is any failure state, was easy to recover and do its maintenance. Okay, faster provisioning of applications and resource required for the tasks, increase in IT productivity, efficiency, and responsiveness. So all these things being achieved in the virtualization. So
Yeah, yeah, correct.
we got it in the virtualization. Then we'll see next what is containerizations. Okay, we saw what is Docker. Docker provides a containerized platform. Okay, then what is containerization? The containerization is a
It is a lightweight VM.
yeah, it's actually light VM, but there are also something which makes it lightweight. That is called
Ah,
containerization is a technique where the
ah,
virtualization is being brought containerization. Okay, whatever the virtualization we saw here, this virtualization making is has become into the containerizations by making and putting everything inside a container. So what it says, containerization is a technique where virtualization is being brought containerization to an operating system level. In containerizations, you virtualize the operating system resources. It is more efficient as there is no guest operating system consuming the host resources. In case of virtualization, what happens? Okay, I have a diagram in next slide. I'll show you. Just let me just go through all this. Okay, host resources, as containers utilize only the host operating system and shares the relevant libraries and resources only when it is required. The required binaries and libraries containers leading to the faster processing and executions. What happens when we put everything into the native area, like in a container? If you put everything inside a container, so when the application will be running, the applications will be running getting the libraries and binaries from the container itself, right? It has not to dependent on the host machine. In that case, what happens, it is become faster, it becomes faster. So whatever the execution will happen, it will get easily from the native area. It has not to go to the man operating systems, right? In that way the execution makes faster. What happens next, uh, as containerizations or containers is a lightweight virtualization technology acting as an alternative to the hypervisor virtualization. It is an alternative to the hypervisor virtualization. Bundle any application in a container and run them without thinking of any dependencies or libraries and binaries. So what is the advantages? Containers are small and lighter in weight because they share the same operating system kernel. Okay, same OS kernel. Does not take much time to boot up. High performance with lower resource utilization. Okay, so here is
So
the
Ranjit, here one doubt actually.
yes, please.
So Ranjit, it don't have OS. It is using the host OS all this or
So okay, so what happens?
container.
Yes, so what happens actually? What it says? Which one I was showing you? Uh,
There only containerization. Uh, there wherever your cursor is there actually.
okay, containerization is a lightweight version technology active as alternative bundles any application without thinking of. No, that's not the one.
No, this is next OS lightweight because they share the same OS kernel. Yeah, that line actually. That one.
Acha. Yeah, containers are small and lighter in weight because they share the same OS kernel. Okay,
OS kernel. Yeah.
yeah. So when we install any operating systems, it will have the kernel itself, right? OS kernel will be there, operating system kernel will be there. So what will happens in case of virtual machines? That's why in the next slide I'll just explain you. Let me just show you this
Okay.
examples.
Yeah. Slide will be better.
In this
Yeah.
virtualization and here containerizations. See, in this case of virtualization, what happens? We have our host operating systems below. We have our host operating system our below, right? I think I had made a slide for this. One second. One second. I had made one good slide for this. One second. I'm just getting the slide where.
Okay.
One second. That will give you more explanation, right?
Okay. Yeah. You got it, Ranjit.
Okay, sorry, I was just preparing this for a different sites to do that. Okay, let me just. Okay, so here if you see in this slide, right, we have operating system here.
Uh-huh.
In case of virtualization, what happens? The host OS is there. Okay, host OS is there. On top of this host OS, we have the hypervisor. Okay, suppose we have the host OS, and then we have comes the hypervisor. Okay, this hypervisor, what it does, it uses to create the different virtual machines. So it creates the virtualizations. So in case of VM1, if you see in case of the VM1, VM2, and VM3, we have three different machines. And in three different machines, to make these machines work, we have the guest operating system installed in the guest operating system installed in this applications. On top of these guest operating systems, we have to install the required libraries and binaries, and then our applications will be deployed. So what happens here, these guest operating systems in this VM1 will be using
Yeah, yeah.
the entire hardware. And the see here the OS will have what different operating system, and that operating system will have one kernel, OS kernel, and the host machine also have a one host OS kernel, right? So here, what how
Mm-hmm.
many kernels we have? Like here, suppose VM three VMs, we have three kernels are there. Okay, three OS kernels are there, operating system kernels, and it is very costly to have different operating system, because in our organization we are not going getting any open source operating system or anything, right? We have to buy the enterprise versions of operating
Licensed
system, which
version.
licensed
Yeah.
versions, which we have to pay more. So
Mm-hmm.
here what
Correct.
happens, this guest OS will not be dependent on anything. It will be whatever applications and anything will be there in this virtual machines, it will be work. But same thing, if we talk about our containerization, what it happens, on top of host operating systems, we need to install one container engine. That I'll show you how to install the container engine. We'll just,
Container engine.
yeah,
Okay.
we'll just install this container engine. Once this engine is installed, what we have to do, we don't have to install any operating systems on the container. We don't have to install any operating system in the container, because what it does, these containers are going to use the host operating systems, the kernel of host operating system. Suppose I have created three containers
Mm-hmm.
in my laptop, three containers in my laptop. So what they are going to do, they are going to use the resources of my laptop, the kernel of my laptop, the host machine. That means that is why it is become faster. In this case, what happens, these guys are using the guest OS kernel, and this also talks to the host OS kernel to use the hardware resources. To use the hardware resources. In this case, it is little slower. But in this case, we are omitting this guest OS things. We don't have to install guest operating systems. So here, what happens? We eliminate the guest OS, then we saved some penny here, right? We saved something for our organization. So we don't have to get this operating system. And again,
But Ranjit, the purpose is also different. Na? Let VM
mhm,
and container both cannot be equal. Like whatever we can do in VMs or virtualization,
mhm.
so same thing cannot be done with containerization. Na? Only thing where container we are just where means it can be executed on the other end actually. Am I correct?
Yes, see, now actually what
Huh.
happens, the same thing, whatever
Mhm.
you told, right?
Mhm.
Whatever we are doing in virtualization, virtual machines,
Virtualization.
maybe same thing we
Hmm.
cannot do in the containerization in container.
Containerization.
But
Huh.
in container also, you can achieve that one. Whatever you want to do in the virtual machines, same thing you can do in containerization. The only thing is
Okay.
here, in first slide we saw, right, the
Huh.
containerization also uses the virtualization. It is also A
Okay.
lightweight virtualization, right? Container is a lightweight virtualization, right? What happens it
Uh,
here? We have suppose the VM1, right? In VM1, what we can do, we can install our container engine, and that what will happen if we install container here, Docker here in these virtual machines? What will happen? These virtual machines will become your containerizations because the container whatever you install will be using the guest OS kernel
this
here.
was yes. Yes.
It will not have again guest OS when we are going to use, because this container is required a machine, and that machine could be your VM, that machine could be your host operating system or whatever your laptop, or you can create any VM and you can install it. It is required a machine to run. But here we are
Restaurant.
creating machine itself. We are creating machine itself. But the
Machine is.
Docker, yeah, the Docker is required to run a machine to execute it. Okay.
But here, Anjit, I got the point actually. So, in container, in the Docker actually,
Mhm.
so containerization, yeah, containerization. So, can I build the code also?
Yes, yes, it is a very good for developer platform. You can build the code also.
Okay, so my doubt actually, because anyway, it's my doubt. Like, let my office laptop, it contains one Oracle VM and VMware Workstation Pro actually. So both. So let why they gave this somewhat heavy weight actually, because sometimes it's hanging actually. So why they did not give container actually?
See, um,
Because yeah.
that is actually, see, container will not create a virtual machine for you. First thing, it will not create the virtual machine for you. So what we need,
Uh,
the container itself is required a virtualization platform to create the containers, right?
okay.
Even though you are going to
Uh,
install Docker, you need a virtual platform, you need a virtualization platform to create the containers.
okay. Okay. Okay.
So that
Uh,
will not independently work. We need the virtualization,
not independently to that. Okay.
not
Okay. Got it.
independently
Got it.
work. We need any virtual.
Okay.
So I'll show you while installing the virtual Dockers and all in Windows, right? You'll see virtual works like Oracle virtual works is required to
Uh,
generate that, because we are going to use
uh,
right different VMs we are going to create. On top of that, we are going to install it. That is required one
mhm.
install. But when we go further, let's see, there is a definition differences between there. What happens here?
Okay. Okay. Yeah. Yeah.
In case of virtualization, it virtualizes the hardware resources. It virtualizes only the operating resources. Okay, virtualizes the operating resources, OS resources. But when in case of virtualizations, we have to create different virtual machines, and different virtual machines also it virtualize the hardware resources. But here it will be only the operating resources.
Correct.
Then it requires the complete OS installations for every VM. For any virtual machines you create to host the applications, you need to install the operating systems to make the machine work. Suppose you are going to,
Mm.
like, let me tell you about a real time thing. When we create a machine in the AWS EC2 instance, right? What do we
Mm.
choose? We choose the image to create the machine.
OS.
Either it is Linux machine or Windows machines or whatever, Linux or Windows, right? So these are the VMs, cloud virtual machines. These are the cloud virtual machines. So for that, what we need, we
Correct.
have to install the operating systems in that machine. Then it will be work, right? So what it says, it records the complete OS installations for every VM. In case of containerizations, what happens? It installs container only over a host OS. So we don't need
OS.
another operating system to install the container. We can install the container on the host OS. Okay. So
Mm.
what happens in the next? It says a kernel is installed again for every virtualized operating system. A kernel is installed again for every virtualized OS. Only the underlying host operating system's kernel is used. That means the host operating system's kernel. This has the kernel, so these containers will use the kernel of the host operating system. But these applications, whatever applications and are using, they'll be using the guest OS kernel, and that kernel will be using the hardware resources of this. Okay, so a kernel is installed again for every virtualized OS, and only the underlying, because as we are getting installed kernel, so it becomes heavyweight and it becomes lightweight for container, and it is limited performance, it is native performance, fully isolated. This is process level isolated. So isolations happens in
Process
both.
level. Okay, okay.
Yeah, isolations happens in both ways actually. It happens in virtualization, it happens in containerizations. But isolations here, if you see, we have three applications, and we have isolated all these three applications in three different machines. So before VM, what was happening? If we have only one laptop or one host OS, we had to install all three applications in on this host operating systems itself. Or else, if this host OS
Separate partition.
separate partitions we have to do, or if it is
Hmm.
if you want to install the same applications, then what you have to do, you have to create another, you have to buy another machine,
Laptop.
another laptop or
Listen,
another
yeah, yeah.
desktop, then you have to install these applications. Okay, so
Huh.
after this virtualization, it isolated this the hardware level also, so you can use those applications easily. And see, this is fully isolated, and this is process level isolations. Now, so this is what about the containerization and the virtualization. So you have to understand fully.
Virtualization.
So we have another, I have another diagram created. Let me just show you that in my next slide. Okay, so
Yeah.
in case of virtualization, what happened? Suppose here I have a total memory of in my laptop actually 18 GB. Okay, my RAM is 18 GB, and I have created three virtual machines here, VM1, VM2, and I assigned 6 GB to this.
Ranjit, this is the RAM, right?
Yeah, memory.
RAM memory or
Yeah, RAM. Memory is
oh.
our random access memory, right? RAM only.
Yeah, yeah, got it. RAM, yeah, yeah.
So
No,
it's not the
18
storage.
actually looking little awkward actually. So,
No, it's okay.
uh-huh. Okay.
So the total
Uh-huh.
memory, uh,
Please.
18 GB, suppose in my laptop, because in companies there will be many GBs, right? Suppose in our laptop we have 4 GB or 8 GB, and sometimes
16 GB, yeah.
16 GB. So in companies you will be fine 32 GB, 64 GB, even 128, 264, like they will be, because based on
Oh,
there are,
256 also there,
yes,
Ranjit, that
yes,
much.
yes, yes. They will,
It will be more.
it will be more.
Oh,
I
more.
suppose.
Okay, okay, maybe. Okay,
It is
okay.
like
I have
it
to.
is in a, yeah, in a slot they will have multiple core, and this
They
will be
can,
like in a 4,000 GB of memory will be there for application like
Oh,
64
okay.
they will allocate.
Okay, okay, okay.
like
Because, okay.
yeah, like our
Got it, got
desktop we have seen, right? There will be two slots available for RAM to install. One,
it. RAM to
yeah,
install.
suppose you have 4 GB RAM and you want to increase more memory, what you have to do, you have to create another 4 GB of RAM slot and put it into that slot, RAM disk, and put into
Correct.
that slot, so it will become
Uh,
4 8 GB.
8
So
GB.
similarly, in the
Uh,
server, in the company infrastructure, actually, if you see, actually, what is that? Those are all only hardwares and machines, right? And lots of network cables.
uh,
If you go there and
hmm.
if your project is required more memory for some particular server, and you have to request your infrastructure administrator that we need to increase some memory, so what they have to do, they cannot increase like that, right? If they don't have memory available, what they have to do, they have to purchase the memory from the market and get that disk put into the slot, and they'll increase the
Slot.
memory. Okay,
More
and they'll
memory.
share that memory with you. Okay,
Hmm.
so what happens here? I have 18 GB of memory, and I created three VMs, okay, three virtual machines, and each I have given 6 GB. Each I have given 6 GB. But whatever applications is installed in these virtual machines, or whatever the application is deployed, in this virtual machine VM1 will be using the 5 GB of memory, and 1 GB memory is wasted. And here suppose it's very small applications and using 2 GB of memory, and the rest 4 GB are wasted. Similarly, if you see here, memory used is 10 GB, but wasted is 8 GB. So whatever 8 GB you already assigned 6 GB means those available 4 GBs cannot be used by any other resources. So that is totally waste. What it says, 8 GB memory blocked and cannot be allotted to a new VM. If you want to,
Correct.
if you want to suppose tomorrow, if you want to create another machines, you cannot reallotted it. What you have to do again, you have to destroy this VM, and while creating you have to assign it suppose 3 GB and assign another machine to 3 GB. Okay, in that way you can do it. But here once you allotted, that is totally waste, you cannot reallotted again. Okay, but in case of what containerization, what happens,
Mhm.
as it uses the host operating system resources directly, it does not depend on the guest operating system. What it does, whatever the memory is allotted, it will be using the host operating system. This container one, suppose the application is only required 5 GB, so it will use only 5 GB. It requires 2 GB, it will use 2 GB, and if it 3 GB and 3 GB. So what is only memory used 10 GB, so we have still 8 GB memory available. If you want to create another container, one or two container, we can still create it. So what it says, only 10 GB memory utilized, 8 GB can be allotted to a new container. That is the benefit of this containerizations in terms of resource allocation. So this is the resource allocation. So when we are allocating some resources, so memory is one of the resource, storage is one of the resource. Okay, so when we are allocating these resources, this is the benefit we'll get it from the containerization. Okay, okay, so here as I said, we
Yeah, yeah.
need another container to be created, so we can
6
create
GB.
another container and it can be created. So
Okay.
that's it, that is it what about. And okay, so let me discuss about the architecture. Okay, here is the architecture. It's about the Docker. Okay, so it's a very simple architecture, guys. If you understand, it's a very simple architecture. What it does, it only has three components. That's one is client, one is the Docker host, and one is the registry. Okay, so what is this client? The client where we'll interact with the host. So we have to use Docker build, Docker pull, Docker run. These are the commands we are executing in the client machine, in the client. So in the client, when we execute, and it will interact with the Docker daemon. So daemon will be in the Docker host. Okay, and that Docker daemon will be interacted with the host machine, and it will execute the containers. Okay, so we'll see in details. Let me show you. um,
Yeah, yeah.
Docker
Okay.
architecture. So Docker, what it says, Docker uses a client server architecture. It uses a client server architecture. So we have a client, and another is a server architecture. The Docker client consists of Docker build, Docker pull, and run. These are the Docker client, the basic things: build, pull, run. The client talks to Docker daemon. As I told, the client talks to Docker daemon, and then Docker daemon, what happens, which further helps in building, running, and distributing the Docker containers. So Docker daemon is the person who takes care everything. Once the client executes the commands, it talks to the Docker daemon, and Docker daemon decides what's and when needs to be done. Okay, so what then next? Docker client
Okay.
and daemon can be operated on the same operating system. Otherwise, you can connect the Docker client to the remote Docker daemon. So these both communicates with each other using the REST API over Unix sockets or network. So what happens? We can separate the client and Docker host also. We can separate the client and host, but we need APIs to APIs or Unix sockets on or a network to connect those to interact or to communicate both client and
Interact, communication.
that is the simple things, because whenever our API will be, suppose think about one applications, the front end applications, right? So whenever suppose the front end applications you can put it in one server, and your backend will be database, your everything will be on another server. You need any APIs or programs to connect to another server and
Connect.
talk to the database, right? Or get information from the database. Same things also, same architecture, client server architecture also applies here. Okay. So as I told,
So Ranjit, here one doubt actually.
yes.
Yeah, Ranjit, sorry. So this whether unique socket that I got it actually socket communication either TCP or UDP
Yes.
whichever.
Mhm.
But REST is like that kind of socket communication. It's a protocol I just know actually.
REST,
But what is that actually?
yeah, this is REST API. That is a simple API, right? As we know that application programming tools. So we
Uh-huh.
have some APIs, small
Uh-huh.
programs that APIs is required to connect. So
Small program.
yeah, so when a developer is doing the development, right, it will be that they will be working actually with the different APIs. They see nowadays in the market, right? Suppose you think
Just to
about a
be test.
payment gateway. Think about a payment gateway.
Mm-hmm.
So what you're doing, you are having one website, and suppose you are selling something in your website, or you have some lectures, videos, and you want to allow someone to register and use your application, and for that you are charging some money. For that, what you need,
Money.
you need a payment gateway to make a payment. So to
Mm-hmm.
get the payment gateway, you have to use the payment, whoever
Somebody.
providing the gateway, their APIs in your application, in your
Yes.
programs, to access their machine, to access their payment gateway. To access their payment, you have
Mm-hmm.
to use the API of the merchant. Then only you can access that.
Mm-hmm.
So that is a small
Mm-hmm.
program. You can say that is a small chunk of software or program. Similarly, we do in
Is
the
a function.
projects, right? Yeah, functions.
Mm-hmm.
So that can be used to
So,
access that.
so in turn, it uses this socket communication then.
Yes, in turn it will be, that is why API
Okay.
over sockets, over a unique sockets.
Oh, over socket. Okay. Uh-huh. Got it. Got it.
So the next thing is,
Means REST API. Well, so yeah, please go ahead. Got it. No issue.
mhm.
Please go ahead.
Okay. So what I said, it has three. It consists of three parts, as I told. It has client, it has Docker host, and it has registry. The Docker client, Docker host, and Docker registry. So Docker registry is nothing but our. It is one of the remote repository. It is also one kind of a repository.
Docker. Mm-hmm.
Dockerhub.com, like we saw github.com, right, for git repository.
GitHub.
Git repositories, what of the source code we maintain in the remotely, the github.com, right, in github repository. Same thing, will maintain all these binaries, all these image files. So image files is a binary file, right? All these binaries will be stored in the Docker Hub, is a remote repositories. Okay, in the remote repository you have to store. So guys, you have to create one account in the Docker Hub, and it's free, open source, it's free to create one Docker Hub account. Okay, like we created GitHub account, same way you have to create Docker Hub account to
Docker. Okay.
to
To
store
registration ourselves.
exactly, you can do register yourself and to store all your images. Now
Images. Okay.
what is Docker client? So, guys, today we'll try to finish all the theoretical part and the basic details about the Dockers. Next class we'll do installations, and we'll do practice on the commands, and we'll see the real time how Docker works. Okay.
Then no task for us then.
Now today we have no tax.
Only just word format we'll just browse and enjoy.
Okay. Um,
Okay, please.
so what it says, it is
Only thing only register. Okay.
yeah.
Yeah, please go ahead.
It is a Docker client is a primary way for many Docker users to interact with the Docker. So That is nothing but your CLI, command line interface, like where you have to type something and get information. The client, okay, and it uses command line
Mhm.
utility or other tools which uses Docker API in order to communicate with the Docker daemon.
Daemon.
The Docker client can communicate with more than one daemon. So yeah, this
Okay,
remember,
okay, okay.
it can communicate with more than one daemon. Suppose you have multiple Docker environments, so and you are writing one API to connect multiple Docker environment, that also can be done because one client can communicate to different daemons. We'll see how this will be achieved in our real time when you create different containers. That time we will see. Okay.
So, Ranjit, why this scenario comes actually?
Uh,
Means let daemon,
okay.
each daemon specific to one, let one container or like that.
Sorry.
Maybe I could not frame properly.
No, 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 no. So daemon, see,
Uh-huh.
daemon, what it does, Docker daemon actually it's a background program, right? It's a program which interacts and which
Around.
creates
Hmm.
whatever the request comes from the client, right? It receives that request,
Hmm.
and based on that, it interacts or it creates the container. So it is not inside the container. It is actually inside your. It is it is actually as I told, right? It is there has only three parts: the Docker client and host. Just forget about this registry. It comes later. The think
Uh,
about this client
hmm.
and Docker host. So Docker host is the server where Docker daemon is there. So Docker daemon takes the responsibility to create the image, to create the container for us. Okay.
Oh, okay, okay,
So
okay.
some scenario will come when we'll see the client will talk to multiple operating systems. So what happens? Suppose you have two different server. Okay.
Docker host let.
Docker host. So suppose you have two Docker hosts, and the two Docker
Hmm.
host means one Docker host in one server and another Docker host in another server, and you have the
Hmm.
client in only one API. That one API or
Uh-huh.
one front end you are going to connect to the different host. So
Hmm.
you can select use. In that case, what happens? Same Docker commands can communicate to different Docker daemons based on the APIs
Okay,
that
okay.
comes
Means
from the server.
through we can segregate here through. Yeah, got it. Yeah, please go ahead. Maybe through IP, if, IP address
And
something, so
yeah,
we
yeah,
can.
exactly through IP addresses because
Uh,
that we have to be. We'll see in this in details. Okay, don't worry. We'll see in details.
correct, correct. Got it.
Okay.
Hmm.
So the next what it happens in Docker host we have Docker daemon containers and images. We have Docker daemon containers and images. So first let's understand what is Docker objects. We have Docker daemon containers and images. Um, so what is Docker object we'll see, and then we'll see what is Docker daemon, and we'll see what is Docker registry, and then we have some architecture discussions. Okay. So what is this Docker objects? Okay, guys, don't worry. I'll share this documentation with you. Okay, and whatever the things I have written it here, just go and use it.
So,
And
Ranjit, sorry, Ranjit, to interrupt. So, Ranjit, you can decide actually. So, is it means because theory that must be completed, no? So, just a lab will see something like another 15 minutes. So, that thing we can practice actually. Means theory let will stop here.
okay,
So, is it fine or
no, 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 no. Until unless we complete,
means we need to?
if you don't,
Okay, okay, okay. Means this
this is related to the lab classes because if you
at the
don't
beginning
understand,
only. Yeah, yeah.
if you don't understand what is object, then you cannot work on that, right? If you don't know what is image,
Okay,
if
okay.
you don't know what is container, then we cannot do the practice. This is
Yeah. No, no,
whatever.
actually I told like this thing let next class will do, but some lab will see actually. That way I told.
Docker lab, right?
Docker lab. Yeah, correct. You
Yeah,
told na today we'll finish all theories.
yeah. No, because the Docker lab we cannot continue until unless we finish that. This is not theory. This is just architecture, right? I'm just explaining
This
the
is okay. Yeah,
architecture.
yeah.
So
Yeah, got it. Okay,
the
Ranjit, please
architect
go
if
ahead.
until unless we finish the architecture, we cannot do the lab classes. So that's that way we have to
Okay, okay,
understand. Yeah. So this because if you don't
okay, okay.
understand client, if you don't understand what is object, and if you don't understand what is daemon and what is the registry, then we cannot do the lab classes, because everything is
Lab also.
whenever I do the lab classes, you will not understand what you are creating. So if you understand what,
What is creating? Yeah.
that is the thing.
Yeah, please, please go ahead.
Okay. So what is a Docker image? The Docker image is a type of recipe or template. Remember, guys, these things you'll get in questions in the interview. Okay,
Interview. Yeah.
sometimes see,
Mm.
people are not asking. These are the basic questions. These are very basic questions. Nobody will ask you what is image, but those questions will come when they feel like this guy has not real working experience. Then they will
Not
come
a
to very
real
basic.
working. So,
Yeah, then they will come to basics. Then they'll just try to understand whether this guy is already has some ideas on Docker or not. Then they'll ask you this basic silly
they'll
questions
expect
like,
definition.
yeah, definition. What is image?
Uh,
If I feel like you have not worked any container, then I may come to the basics like what is container. Then can you explain what is container?
mm.
Then you have to tell them.
Yeah.
Same thing. So what is the image? The Docker image is a type of recipe or template which can be used for creating the Docker containers, including the steps for creating the necessary software. That means the image in our AWS classes, we saw creating of images. Guys, can anybody of you tell, any one of you tell
Mm.
how that image created? We had seen, right, creating of image, how that
Yes.
image created.
Uh,
Taking a snapshot of only executable what is there on
Exactly.
the server itself as well as data.
exactly. Snapshot. Yeah, correct.
So what we have to do, we have to take the snapshot of the volume,
Snapshot.
and by
Uh,
using the snapshot, what we did, we create one operating system image, and that image,
mm.
what it contains, it contains the snapshot, the backup whatever was taken, and the snapshot contains everything in the machines, whatever is there in the volume, right, all the details. Same thing,
Correct.
when
All
we
that.
are going to create the Docker image, we have to write down the steps what needs to be done. First we have to see, suppose it is kind of a template, it's kind of recipe or a template what you are going to use. So we have also seen creating the templates, right? Template configurations in our AWS classes. What we had set up in the templates, what sort of machines we need, what type of instance we need, what type of network we need, what type of storage, everything was added in the template. And when we execute that template, it will create one instance for us. Same thing here. What type of container do you need? Everything you have to write down in a Docker file and execute that. That will build one image. That's why it's called a template, which can be used for creating the container. So to creating the container, first you should understand what is your requirement to create the container. Then based on that, you have to create the image. Guys, did you understand?
Image.
If you understood this line clearly,
Yeah, like EC2 instance. No?
yeah, sorry, like,
Like let EC2 instance. Now we are taking what is our OS requirement, what is the memory, all this. No? So same way here Docker also we need to make a note like what are my requirements and what are the dependencies. So on basis I need to create.
exactly. So what libraries you need,
Yeah.
what configuration file you
Mm.
required, what binaries you need, what operating system you need, everything, what file you need, what applications you want to deploy, everything you have to put inside the image. That image you have to,
Okay.
not image, that you have to inside a file. Then once you build that file, it will create the image. So those things we'll see
Image.
in our later classes. That is a different Docker file session is there. Okay, so that
Mm.
is what the image. And the next is what is the Docker container. The container is actually a type of virtual machine which is created from the instructions. Remember, is a type of virtual machine which is created from the instructions found within the Docker image. So the requirement, whatever need required for the container, everything will be found in the image. Based based on the image set of the Docker container will be created, which is created from the
Okay, okay.
instructions found within the Docker image. So what it says
Mm-hmm.
again, you can say it is a running instance of the Docker image, which consists of an entire package required to run an application.
Uh-huh.
Okay, so the image is has everything which is required for an applications and for a container to run. And the container, what it holds, it will be holding the application, what applications you need. Okay, so don't worry guys, when we do one small program and small
Lab, yeah, yeah.
lab, then
Mm.
you will understand what how this container looks like and how it works. Okay,
Okay. Yeah, yeah.
the next
So
one
what
is
are the things we are doing to create container? Yeah.
exactly that everything will know.
Mm-hmm.
So similarly, Docker
Ah,
daemon.
correct.
Docker daemon helps in listening the request for Docker API, and it helps in managing the Docker objects such as Amaze and all things. So these things I'm not just telling you, I'll just share with you, and you can read through. And we don't have to focus more on the Docker daemon. Okay, this part we can ignore it. And the next one is the Docker registry. Docker registry. So
So sorry, Ranjit, to interrupt actually. So Docker daemon part, we are not dealing anything. Means DevOps engineer.
see, Docker name daemon is a backend program. So we are not doing any because it
Oh,
comes
okay.
by default with Docker installation. So we are not going to do anything
Oh,
with
okay, okay.
Docker.
Daemon will be
It's a
there. Okay, okay.
background program. But you should know how the
Okay.
background program works. That is what it is explained here. Okay, what is this background
And how to
program?
use also, yeah.
No. We cannot decide how to use it. That will be used by the Docker client itself.
Oh, okay.
So we don't have
Okay, okay, okay.
the daemon. We don't have control on. That is what it says. Docker
And
daemon can communicate with other daemons to manage. Okay, so okay, let me just explain you what it says. Docker daemon helps in listening requests for Docker API. That means whatever the request will get it from the Docker client, it will listen.
client. Mm,
But we cannot
mm,
decide what request it will listen. Whatever the request you will type on the Docker client, it will
mm.
receive. Okay, what it says,
Okay.
it
Mm,
helps in managing the Docker objects such as image, containers, volumes, etc. Daemon is used to build an image based on the user's input and then save it into the registry. That also can be done by the daemon. So in case
Daemon.
you don't want to create an image, then simply pull an image from the Docker Hub. It's a simple thing. Okay, I'll just explain you what is that and how it is. What it says, in case you don't want to create an image, see, there will be two type of images. One is inbuilt, which is already built by someone else. You can use those images in your and
Mm,
host your applications. That is, you can find it in the Docker Hub registry. You can find it in the Docker Hub. Ready-made images will be available. You can directly download or pull those images and use here and to create container. You can do that. Also, you can
mm.
write your own image. In the real time, we don't pull any images from the registry and directly install
Existing
any
register.
container. Okay, what do? We get some images, base image, that is called base image. Okay, I'll explain those things later, don't worry. Base image, and that base image, on top of that base image, we write our own instructions to create our own image. In companies, in organizations, we write our own image file. We don't get default images whatever available in the Docker registry and then use it. Even though we downloaded the images, we need to modify it based on our requirement. We can also modify it. We can add new functionality, we can add new instructions, we can add new updates, anything we can add it and then make another image. So we'll have another versions of image. Again, you can say image is a layer of instructions, multi layers of instructions. It has multiple layers of instructions. Suppose
Mhm.
suppose Siba created one image for one of the applications, and I am working in his team.
Mhm.
And what I need to get his image. And suppose this image, whatever is he has, is working properly, but it require one set of files or one set of library to make new functionality. So what I need to do, I just need to get the image file from Siva. Okay, the Docker file, if he has, I have to get the Docker file and add some new instructions and create another image. It will create another image,
Okay.
and that image I
Mhm.
can use to create the container. Okay,
Container. Mhm.
so that is what we have to understand, guys. These Docker concepts will not you cannot be mastered in 1 week or 2 weeks. So you have to give at least some time to understand and create multiple containers and see the behaviors and see how it works, do different ways how we can create containers and images and all this. Then we will get master. Okay,
Yeah, correct. Because first for terms, it will take some time
it
to
will take some time to
get adjust to the terms,
Map,
map
map the
with the
term
terms.
with real term.
exactly.
Yeah, yeah, correct. Uh,
And what Docker daemon also does, then in case you want to create a running instance of your Docker image, issue a run command which should create a Docker container. So whatever command you will execute, that will be taken care by the daemon. You will not see the daemon. We can see the image file, we can see the registry, but we cannot see the daemon. Daemon is a backend program. Whatever the instructions comes, it just receives it and acts on accordingly. Okay, so also what it says, Docker daemon can communicate with other daemons to manage the Docker services. This is what the Docker daemon it does. Okay, then what is this Docker registry? It's very simple. The Docker registry is a repository for Docker image. Once this sound stop, oh, okay, the Docker registry is a
yeah, yeah.
repository for Docker images, which is used for
So it's
creating
like a hub. Okay, okay.
the Docker containers. Yes, it's like a hub where you are storing all your
Mhm.
images. So this Docker hub also actually has private as well as public repositories. So
Public.
it is
Okay,
a
okay. I
free.
like that. Okay.
Yeah. Similarly, we have GitHub, we have public and private.
GitHub.
Similarly, in Docker also we have public and private repositories, because
Mhm.
in organizations company we never share our things to anybody, right? That for that case we have to go for private. You have to go for a private
Private.
Docker hub, and you'll say store all your registry there. Okay, all your images there. Docker registry is a repository for Docker images which is used for creating the Docker containers. One can use a local or private registry or use Docker hub. So what it says, you can create one your local registry means you can create one server. Even you can in AWS, guys. This is a question for you. If you understand clearly, you can answer it. In AWS,
Uh-huh.
which service should I use to make and to store these images? To make that one is my registry, private registry. Which service should I use? Is Bablu there today?
S3.
Template is there, na?
Bablu is there, yeah. So yeah,
Templates will be
Pablo.
there.
yeah. Yeah, Tapan bhai said correct.
Pablo is there.
It is Tapan bhai said correct. It is
Oh, then
S3.
S3 bucket.
So
Okay, okay.
S3 bucket we can use to store the images, and that we
Uh-huh.
can make it as our private registry. We don't have to go for Docker Hub.
Uh-huh.
Okay, that we can store it.
Uh-huh.
Now let's see. So Docker registry is gone. Now, guys, this is too much. If I go further to explain this monolithic and microservices architecture and
Here and there, correct.
lot more things are there. So I just don't want to. Okay, in next class we'll see. This will explain actually, guys, this microservice architecture, right? This microservice, this Kubernetes and Docker actually containerizations. Due to this containerization, this microservices is possible. Uh, okay, I'll explain maybe in our next class. So we are good with of the Docker registry. And one thing I'm going to tell you. So just go and do hub
Register,
hub dot
GitHub.
docker hub.docker.com hub.docker.com and register yourself. Okay, and just try to see, it's very simple to sign up. Just sign up and register for yourself. And as I telling, maybe in our next class I'll show you what are the images. If you search any image here, suppose you want Tomcat server to use, you can use Tomcat. Just search for Tomcat. You'll find hundreds of, not 36,722 results. That means 36,000 images are there. 36,722 images available in this Docker Hub. And which image you should use? The image which is has the official image tag.
Official,
This is
the blue tick mark.
yeah, this official tag actually
Uh-huh.
is actually where which one you should use it. And this is for Tomcat. And suppose you want to use for Jenkins. Suppose in our one lab classes we'll create one container, Jenkins container. What you can do, just do Jenkins. We'll find, see, we have official image Jenkins container also.
Official.
So this is
Okay.
Jenkins image you can use to create a container, and you can build all your applications in this container itself. You don't need a server. You need a container server. You'll have, that is what Tapan Bhai was asking, right? Why we have different virtual machines in our laptop, right? We can create container and do the development. Yes, you can do. Suppose,
We can do it here.
yeah,
Okay.
suppose you need you need one um, SDK, software development kit, and you need a tool for, suppose you are doing .NET applications, and for that you need, suppose VS Code, suppose Visual Studio or Eclipse. So you can just do for Eclipse image, just search for that, you'll find it Eclipse, lots of images for different tools, right? We can get, these are the official images. What it has happened, official image for OpenJDK and Eclipse Open 9 are there. So if you use this container, it has already this OpenJDK for Eclipse
Everything.
available. Then you can easily use it. This is Eclipse Temurin versions, and this is Eclipse Mosquito version. Eclipse has different versions, so you can use it. Okay. So a development tool, you don't need don't need a machine to install it. You can create a container and you can develop your codes there, right? So you can do lots of things you can do, guys, if you understand the basic, if you understand the basic functionality, and if you want to try to do some R&D work, you can do, and you'll get really expert into that, and you can understand how it works and what you need. Your requirement you will easily understand. Okay. So you just try to sign up and see what are the images available. If you want to see Apache server, HTTPD server, type HTTPD, and you'll find one HTTPD. See, HTTPD official image also there. Anything, whatever you want, you will be fine. Even if you see Hello World, one Hello World official image will be there.
Okay. It's very popular.
Yeah, there are lots of
World is
Fast program.
so lots of things will be there, guys. So you can just do and find it out, and just first sign up. Okay. And in our next class we'll discuss about
Yeah.
this monolithic things and mm, microservices thing, and then we'll do direct installation, Docker installation, and then we'll jump into the Docker programs, Docker commands and everything. Okay, we'll see how we can
Yes.
create containers and everything.
Yes.